The next topic is sequencing jobs that are waiting in front of a workstation, work center, and you want to prioritize the jobs in other words, in which sequence these jobs must be taken up for processing, or it's also called dispatching. There are several rules that you can follow. There are actually many rules. Your textbook discusses these 4 plus one more. That is what is called critical ratio. We'll get to that in a little bit. But these are the 4 that your textbook describes. FCFS is first come, first served. Now, first come, first served is a good rule if human beings are involved. So if it is like a hospital or a doctor's appointment or car mechanic shop, then first come, first served would be a good rule because it incorporates a fairness in that rule. But if it is a job shop where there are no customers sitting in the workstation, first come, first served has no benefit, inherent benefit in it. It turns out that it is not as good a rule as the others. So we were not going to, we know what it is, first come, first served, so there is nothing further to be said. So we will do the computations only for SPT and EDD, that is shortest processing time rule, and EDD is the earliest due date rule. So both of these rules are pretty easy to incorporate. The longest processing time rule, which is the opposite of SPT, the textbook describes that, and I'm not going to talk about that for this reason. LPT rule is not a very good rule. If you look at the criteria for comparison, it turns out that LPT doesn't give you good results at all. Okay, so when you're saying good results, what do we mean by good results? How do we compare these rules? And once again, we talked about this early on. There are 2 basic things. One is keeping the work in process inventories low. So that's one criteria, and there are 2 or 3 different measures that we can calculate that would indicate our amount of work in process inventory that we will have. Then the second criterion is our ability to meet customer delivery promises. So lateness, in other words, lateness in completion with respect to due date. So these are the 2 things that we will compare, and against these 2 comparison measures, LPT does very poorly compared to SPT or EDD. So we are not going to talk about LPT also. Only SPT and EDD, and then there is one other rule which is critical ratio rule, and that is slightly different than this. Here we only look at the jobs that are waiting in front of a given machine, and we only look at how much processing time it will take in this particular machine. That's it. You're not considering where this job will have to go after it gets completed in this machine. So you're not looking at farther ahead. You're only looking at this particular machine. It's a more myopic view. So here is an example. We are given the processing time in days or hours, then job due date, okay, again relative to today, how many days till due date. Then you arrange them. The first come first served is this. Okay, we're not going to worry about that. And then we calculate these 4 measures, and here are the formulas. We will go through worked out example in just a few minutes. Then SPT would be the smallest processing time first, and then the next smallest, all the way to the last. And then again, you compute your completion time. Float time is completion time. So it completes in 2, 2 plus 3, 5, 5 plus 6, 11, and so on, and compute the job lateness, and then compute the 4 measures here. And we have the EDD. So you take the due date and order the jobs according to the due date, smallest to the largest, and again do the computations. Then we have the LPT sequence. As I said, we are not going to do LPT, but here is how it is done. Largest processing time backwards of SPT. Now you compute the measures. Now here is a summary of all the measures, and as you see, both first come first served and LPT do not do very well. So when you look at SPT, the first three measures which relate to work in process inventory, okay, SPT does very well. Okay, especially average number of jobs and average completion time. The utilization metric is slightly it's really about utilization of jobs, not machines. So for work in process inventory, the first and the third are more precise measures, and in those two measures SPT gives you the least possible values. And when you look at the average lateness, you see that EDD gives you the lowest value. So that's not generally the case. SPT rule will minimize work in process inventory, and EDD will minimize the lateness value. So depending upon which one of these two is your priority, you may choose one or the other for a given time period. So it could change. At one time, delivery promises are slipping, so you use EDD. Now, a couple of months later, if there is inventory is the problem, delivery promises is not a problem, then you may switch from EDD to SPT. So it is not something that you commit to on a long for a long period of time. You can change it anytime you want.